Alright, hello everyone, you're welcome back. Okay, so I hope your break was nice. Yeah, mine was to have a little rest and then it was fruitful, so we are back. Now recall that we have been on the exercises of Maths AMET 102, which you can also call MTH 102. Okay, so and this is still the module 1. So recall that we in the first section, which I'm going to title part 1, this one is part 2. In that first section we did question 1 to 5. Okay, so in this particular section we hope to exhaust the remaining 6 questions in this module. Okay, so we are going to be hoping to finish up to 6 to 11 of them. That's 6 to 11. Okay, so let's see. So we are beginning from number 6. Okay, remember we stopped off from number 5 where we talked about piecewise functions, and there we said that a piecewise function is a function that has more than one defined function in one. You can have 2, 3, 4 defined on different intervals of the real line. Okay, so and the value of x at every point determines the function you will use. Okay, so let's go. Number 6. What is in question 6? Let's see. Okay. Okay, let me write it out. So it says evaluate the limit. Okay, so this one has to do with limits. The limits of x squared plus 4 all over, minus 2. This square root stops here. Then you have minus 2 all over x squared as x tends to 0. Okay, so when you have this kind of limits, how do you handle it? Meanwhile, generally, what is limit? Now remember I told you that limits of a function f of x as s goes to a, for instance, this is how to read it. Your x, which is independent variable, must be going to a point. So you're trying to determine the maximum value that the function will take, assuming your x variable takes a maximum value of a. Okay, so and we said that the general definition is just a substitution. You substitute your x as your a, that's evaluation. Okay, however, there are some functions that if you do a direct substitution, you are going to get an invalid or an undefined solution, and that's actually what we do not want. We don't want an undefined answer. Okay, so when you have such situations, for instance the one we are giving here, if you do a direct substitution of 0, your denominator will already be 0, and you know we don't want denominator to be 0 because it will be undefined. Okay, so once that situation is seen, you will try to do something else. That's to try to simplify the fraction or the function you have first before then still doing that substitution, because it will still end with substitution of x as this value. Okay, so there are some cases where you'd have to use difference of 2 squares. For instance, if we give you limit of, let's say, x squared minus 4 all over x plus 2 as s goes to minus 2, you know that if you substitute here you are going to get 0. So what do? You simplify this. This is the same thing as x plus 2 into x minus 2. Okay, and then the x plus 2 will help you cancel out the denominator. So by the time you now make your substitution, you get negative 4. So it is easy to handle. That's for that case. Now there is also another case where you would have to apply L'Hopital's rule. For instance, even the case I just removed, L'Hopital's rule will work there. Of course, I'm going to show you for L'Hopital's rule, you're looking for a situation where a direct substitution is going to give you 0 over 0, or infinity over infinity. For instance, look at this. If I do a direct substitution of x as 0, sine 0 is 0, and the denominator is 0. So when you have such case, you apply L'Hopital's rule if simplification cannot work. Of course, you cannot simplify sine x into any other thing. It worked in this one I did above, because I could simplify this to something where I can cancel out the x plus 2 that is below. Okay, so but in this kind of case, you cannot simplify anything, so only L'Hopital's rule will help you out. So but meanwhile, there is also a third case where L'Hopital's rule may not work, even though it will work. Like in this case, L'Hopital's rule can work here, but L'Hopital's rule will be a more difficult approach to take. That's trying to differentiate the numerator and the denominator, which is your L'Hopital's rule. And of course, you are going to do it like 2 times. So in such a case where there is a presence of a radical, we are advised to rationalize. So rationalize your numerator. If you do that, what is the conjugate of the numerator? Just change this minus to plus. Remember, rationalization is to multiply by the conjugate. Now, so if I multiply the numerator by the conjugate, I will balance it in the denominator by multiplying by the same thing. Remember, it was not given in the question. We are the ones introducing it. So you will try to balance it out. So I'm going to multiply this and then by this. Okay, so let's see what that is going to give us. So we will have the limit as s goes to 0 of, so let's now multiply the whole of this, multiplying the whole, oh my god, so remember, it's what is here that we should write here. So this thing is 4 and not 2. Okay, so what we are supposed to have here is 4. Okay, so this will multiply this to give us, of course, you know that square root of x times the square root of x is going to give you the square of this, which will cancel to give you only x. So if we multiply this, we'll get only the thing under the square root, which is x squared plus 4. Now, remember, in difference of 2 squares, if I have a squared minus b squared, it is equal to a plus b. We stated this earlier on, times a minus b. So if I have it in this form, that means I can go to this other side, a squared minus b squared, and that's the form of the numerator. So it's enough to just multiply this, then say minus, then you multiply that's square this, you get this, minus, then square this one, then you get 4. Okay, all over. Now the truth is that even if we open that bracket, you still get that thing we have up there. Okay, so all over, this one will now multiply. So you have x squared into the root of x squared plus 4, then plus 2. Now you are going to notice why I didn't bother to open this bracket, because from here you are already seeing that 4 is removing 4. So you just have the limit of x squared all over x squared into the root of x squared plus 4, then plus 2. Okay, so as your s goes to 0, so what happens is that this will take away this to just give you only 1 here, and you are done. Immediately that x squared below is removed, then a direct substitution will not give you 0. So you can go ahead and substitute. No need writing out this again, just substitute. So you have 1 all over the square root of, if we put our x as 0, we'll have 0 squared plus 4, which is 4, then plus 2. And that's going to give us 1 over square root of 4 is 2, plus 2 is going to give us 1 over 4. So the solution of that is 1 all over 4. Okay, so we go over to the next one, which is question 7. And question 7 says, let's see it, says is another limit. Is asking us to evaluate. Okay, so here we are to evaluate the limit of 3 all over x raised to the power of 3 plus 1, okay, as x goes to infinity. Okay, all right. So when your s goes to infinity, how do you evaluate the limit? Okay, so there is a simple way to do it. Okay, and what is that? All you need to do is come into the function you are given, look for the x with the highest power. When you get it, use it to divide every term in that function. So I'm going to use x to the power of 3, which is the highest x, to the highest x with a power. In fact, that's the only x there. And so I'll use it to divide every term. It will divide 3, divide this, and divide this one. So all over, if x raised to the power 3 divides this, you get 1, plus then you have 1 all over x raised to the power 3 as s goes to infinity. And then before we do the next step, there are some remarks I want you to note here. And what are those remarks? When you have infinity plus x, x means any number. That means if you add infinity to any number, infinity is actually a very large number. So if you add something to it, it will now be even larger. So it will still be infinity. And if you do infinity minus any number, you don't know how large it is. It is very large. So no matter what you remove, it will still be infinity. If you multiply infinity by anything, that's bigger infinity. If you divide infinity, so this one I want to say now is very important. If you divide anything by infinity, it gives you 0. Very important. How did we get that? Because recall we have been saying that if you divide anything by 0, that is undefined. That's undefined is actually infinity. So if you just switch this position, this one come here, this one goes here, so you will get that anything over infinity is equal to 0. And that's how we got that. And that point is what is important for us here. How? Because if I now do a direct substitution, I'm going to have okay, let me even remove the limits because I'm already doing substitution. So if I put infinity here, of course infinity to the power of 3 will be infinity, all over 1 plus 1 over infinity to the power of 3 is also infinity. So here you can see 3 all over infinity. Remember, anything divided by infinity is 0. All over 1 plus 0, and that is 0 over 1, which is equal to what? 0. Okay, so the solution of the limit given to us is equal to 0. Meanwhile, take note of this remark. Okay, and that's all for number 7. So you can see that it appears that our break helped us, so our speed has increased a little. Okay, I'm trying to reduce this a little bit. Let's see, I think the board has finished. Okay, can I do the next one here? Let's see. Okay, so let's do the next one, which is question number 8. Okay, it says that where is it? Determine whether, so we are to determine whether the function h of x equal to x raised to the power 3 minus 2x is even, odd, or neither. Okay, so when it comes to, and I think that's another point you need to take care of, types of functions. So please take note of that, types of functions. So there you are going to see even and odd functions. You will see one-to-one, onto functions. You also see bijective, surjective, and the rest of that. Okay, so now let's go. So how do you know whether a function is even or odd? I'm going to quickly write the definition up here. So for even function, we are told that if I have f of minus x, that means if you substitute your x as the negative of it, that it should be actually equal to the positive one. It should be equal to f of x. That's even. What about odd? Okay, meanwhile, before I go to odd, examples of even are many. For instance, cosine is an even function. If you press in your calculator the cos of 30, you will discover that it's actually the same thing as the cos of minus 30. Okay, so our cosine is an even function. There are other ones, for instance, x squared. In fact, all even powers of x are all even numbers, because if you do your x as minus 3, for instance, and square it, it will still give you the same thing as doing only 3 squared. Okay, let's go. What about odd? Odd is that when the opposite of this happens, if I have that f of minus x is equal to the negative of f of x. Okay, so when it retains the minus behind the function, then you say it is odd. An example is sine. If I have sine x, if you put your x as 30 and put your x as minus 30, they won't give you the same thing. This other one, you can check all of these things that I'm saying. So it will give you the negative of this. This is 0.5. If you press this one, you will get minus 0.5. So you get minus 0.5. Okay, so that's what it means to be odd. Now, it is possible for a function to be neither odd nor even. In such situation, it means that it does not satisfy this, neither does it satisfy this one. So you say that it is what? A neither function. It is neither odd nor even. Okay, so and how do you handle how do you know whether a function is odd? Okay, I think my board here is full. Let's go to a new page so that we will bring up, remember it is h equal to s cubed minus 2x. That's what we want to check, if it is odd or even. Okay, remember it is still question 7. So let me recall our h here is equal to s raised to power 3 minus 2x. Okay, so all you need to do now is just to get your h of minus x. Remember, this is h of positive x. So I'm writing it this side so that we will compare the two. So what is our h of minus x? That means we are substituting x as minus x. So that's going to be minus x raised to the power of 3, then minus 2 times our x now is minus x. So let's simplify. If you cube this, you're going to get minus s cubed. Then if you multiply this, you're going to get plus 2x. Okay, let's try to bring out minus sign. Let's see if what will be left in the bracket will be the same as this. And of course, if you bring out this, this is going to become s cubed, and this one will become minus 2x, which is exactly what you have as your h. So you can say that h of minus x is equal to minus h of x. Therefore, that function is what? Is odd. Full stop. Is an odd function. Okay, so and that completes for question 7. So we move over to question 8. So what are we expected to do here? The question says, okay, I think what we just did now is 8, not 7. Let's go to the previous page. Oh, sorry, it's 8, not 7, please. Okay, the one we have now is 9. Okay, we had done 7 earlier. So this is 9. let's correct here. So this one is 8. Okay, so the one we did here is 8. So we are already in number 9. Okay, meaning we have just 2 left after this. Now number 9 says we should find the function, find the limit. Okay, still talking about limit. So limit of the function e to the power of 3x minus, okay, I think that minus is down, minus 1 this way, all over x, and then you're taking x to 0. Okay, so this is what they're asking us to evaluate. All right, so you must know how to do all of this, and that's why I'm showing you. So what do you do here? A direct substitution will not help. Let's check it, because you already have x in the denominator. So if you put your x at 0, that wouldn't work. Okay, so but let's check what will happen up if you put x at 0. E raised to power 0. In fact, anything to the power of 0 is 1. So we have 1 minus 1, which is 0. So this, by direct substitution, is giving us 0 over 0. And automatically it satisfies the L'Hopital's rule. Remember I said that the L'Hopital's rule is a way of simplifying or evaluating limits using differentiation. And what did it state? It says that once this condition is met, 0 over 0 or infinity over infinity, that my limit, if I have the limit of f of x over g of x, that it is equal to the limit of f prime of x all over g prime of x. Meanwhile, what's the meaning of prime? Prime means derivative, that's differentiating. That all you need to do is differentiate the numerator, and differentiate the denominator, and then substitute again. If you substitute and you get a valid answer, then that becomes your answer. But if you don't, then if it gives you 0 over 0 again, then you differentiate again. Meanwhile, I'm not sure I mentioned, there are some functions that don't have limits actually, that no matter how you do it, it will give you undefined solution. Okay, so let's try to apply our L'Hopital's rule here. So this is going to be limit as s goes to 0. So I'm going to differentiate up. Now remember, like I said, we are going to be learning all of this. So how do you differentiate exponential function? You are going to bring it down the way it is, e to the power of 3x. Then you multiply it by the derivative of the up one. If you differentiate 3x, you will get 3. Then minus, if you differentiate constant is just a number that doesn't have any x. If you differentiate a constant, you will always get 0. You will see all of this under standard derivative. So this is going to give us 0. So no need writing it, and that is all over. The derivative of x is 1. Actually, if you differentiate something like, let me say ax, where a is a constant, you will always get a. So if my f of x is equal to ax, then what that means, so what that means is that if you differentiate my f of x, you are just going to get only the constant. So if I differentiate 5x, I will get 5. If I differentiate minus 6x, remember with respect to x, then I will get minus 6. This is how we write it, derivative of y with respect to x. So if I differentiate this with respect to x, I'll get 5. If I differentiate this with respect to x, I'll get minus 6, and so on and so forth. Okay, so and that's how we got 1 here, because your x is the same thing as 1x. The coefficient is actually 1. So if you differentiate it, you just get 1. Okay, and what do you do again? Then you can write out what you have gotten to be in a better way. So let's try writing it. This is going to give us the limit of 3e3x all over 1. Of course, you can remove that 1 now as x goes to 0. So at this point, the denominator is gone. You can substitute anything. Once there is no denominator, that's actually what we are careful about. Once there is no denominator, you can substitute. So if I put my x as 0, I'm going to get 3 into 3 times 0, which is 0, and that is equal to, remember I said that e to the power of 0 is 1, so 3 times 1 is going to give us 3. Okay, so the solution of 9 is 3. Of course, that's quite interesting, very interesting. Okay, so we go over to number or question 10. Okay, let me try to write it out. Okay, it's yet another limit. They said here, evaluate. Let me put that evaluation. Okay, it says evaluate the limit of we are given e to the power of 2x, then minus 2x minus 1 all over x squared as x goes to 0. Okay, so this is what we are expected to evaluate. Now let's go. Meanwhile, I've shown you how to differentiate exponents, so that one is not an issue. Okay, so first of all, let's do a direct substitution. You're going to get e to the power of 0, which is 1, minus this one will turn to 0, so minus 1 all over 0 squared is 0. So this is giving us 0 over 0. Another L'Hopital's rule emerges. So what do? You will apply L'Hopital's rule, which means we are going to differentiate. So this is going to give us the limit of all of those blah 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 as s goes to 0. Well, let's differentiate. So the derivative of this, remember what I told you, you will bring it down that way, which is e to the power of 2x, then multiplied by the derivative of 2x, which is 2, like I told you, and then minus the other one now is going to give us the derivative of this. Remember what I told you, it will just give us 2, and that's all over. Then here, if you differentiate x squared, now look at the definition for differentiation. If my y, that's for polynomials, if my y is equal to x to the power of n, then the derivative of y with respect to x is equal to, your power will come down and multiply this, and then you subtract 1. That's actually why the derivative of a constant is giving you 0, because if you have a constant 2, for instance, there is x attached to it, x to the power of 0, because x to the power of 0 is 1. So if you multiply, you still get 2. So if you differentiate this now, what it means is that the 0 will come down to multiply this, then you subtract 1. So no matter what you're subtracting, it's no longer important, because 0 will take everything to what? 0. That's why the derivative of every constant is always 0. And the derivative of a number that just has x is always equal to the number, because the power of this x is 1. And so if you want to differentiate, you bring down the 1 to multiply everything, and then you do 1 minus 1. And of course, 1 minus 1 is 0, and x to the power of 0 is 1. And 1 times 5 will give you 5. So this will eventually give you the constant. Okay, so I want you to take note of all of this. Recall that, like I said, we are going to look at them again holistically. Okay, let me leave this one here and then use it to differentiate this. So see what we are going to have now. Okay, sorry. Okay, I was writing here. So this is going to be 2 will come down, then multiply x squared, then you remove 1. And if you remove 1, the power will be 1. So I'll just have only x. Okay, so now you will try to substitute again. Remember what I said, that once you differentiate, you substitute and check if it has balanced, if it's giving you reasonable number. And of course, so far as there is x in this denominator, there is nothing to check, because it will always give you 0, right? So our interest is actually to look for how to eliminate that x. So we'll differentiate again, and to do that we will have limit of, remember what I said, So invariably it's just the derivative of this that is coming down, and if you differentiate this, you get 2 again. That 2 will multiply the already existing 2, so you have 4e2x. Then of course this whole one will turn to 0 because it is a constant, and the derivative of a constant is 0. So all over, if you now differentiate this, now you will now have 2. So immediately that x disappears from the denominator, then you have peace. And so we can now do our direct substitution, and that is going to give us, a direct substitution is going to be 4e, of course the whole of this will turn to 0, all over 2, and e to the power of 0 is 1 times 4 is 4 over 2. Your final answer is equal to 2. I believe this is beautiful, and I trust that you are grabbing it. Nothing serious here. Okay, and we are here in the final question for this module, and that is question number 11. Okay, so let me open up my next page. Okay, number 11, let's write it. It says find the value of x. Let me write it out. Find the values of x for which f of x is equal to g of x, given that f of x, let me still use another color here, given that f of x is equal to the square root of 3x plus 1, and let's use this, and g of x, no, and g of x is equal to x plus 1. Beautiful. I think this is very amazing. Okay, very, very beautiful. All right, so how do you do that? Okay, so this question, like I said, is very nice. So they are asking us to find the value of x that will make this f of x to be equal to this g of x. So if you want the f of x to be equal to the g of x, all I need to do is, since we want f of x to be equal to g of x, all that you need to do is to equate the two of them. So you're going to have the square root of 3x plus 1 is equal to x plus 1. So you will now solve the equation that is formed to now get the value of x. That's all. So of course 1 will cancel this one here because the signs are the same. So you just have the root of 3x is equal to x, and then automatically I can take the square of both sides, and this will go over here, or this can go over here to become square, so which will give me 3x is equal to x squared, and immediately a quadratic equation emerges. And what do? You will try to solve it. Take your 3x to this side. If I do that, I am going to have x squared minus 3x, because when 3x crosses it will become negative, and everything will now be, the only thing left here will now be equal to 0. Okay, and so what do we do next? We will now solve this. Bring out x. X is common in the 2, so you have x into x minus 3, all equal to 0. And so you have a product. And remember, whenever AB is equal to 0, the implication is either that A is 0 or B is 0, or both are all zeros. Okay, so this is common math, and although there is a section of math or a branch of mathematics where this may not always be true. and then we call such numbers that behave that way zero divisors, or such, they are actually algebraic structures. Any algebraic structure that behave that way, we call them zero divisors. Okay, but then that's not where we are. It's not your level yet. Okay, so what do we do now? So we apply that. So this now means that either that x is 0 or that x minus 3 is 0, and you are done. Therefore our x is equal to 0, and then our x is equal to positive 3. If you take minus 3 to this side, so you get 0 and positive 3. And that's to show you that the person that structured this question knows what he's doing or she is doing. They said values, so meaning that they expected at least 2 values for x, and that shows that our solution is in order. All right, that brings us to the end of module 1. So we took 2 sections to handle module 1. Okay, so, and yet again we are going to stop here. Okay, so that we will now know that the next section will be the beginning of module 2. Recall that I said that module 2 has 44 questions. It's actually nice. Oh my god, up onto 18 pages. Okay, so we'll take it one at it. Okay, sorry, that 44 is actually a continuation of the other one. So your module 12 continued with number 11. So if you, sorry, number 12. So this one ended with 11, you know. So the implication is that if you remove 11 from 44, so there are only about 33 questions in module 2. Okay, so thank you very much. Have a very nice time as you have your rest. The next section may be later, maybe another day, and then we'll continue with that. Good night, everyone. See you in my next video. Meanwhile, kindly subscribe to my channel. I forgot to say that in the first section. This is to support the channel, to get the content to other viewers around the world, okay, so that people will see the beautiful thing we are doing on the channel. Please kindly subscribe, and then also share with your friends, with your colleagues, and then give a thumbs up and give a comment as much as possible. We'll see you in our next video. Bye.